We're going to move straight on to the final talk in this first session. So Phil, hi Phil.
Hi.
So Phil Christopher is from Huff and Puff. He's also representing Bale UK today. So we've covered timber frame, various options. We've looked at an ICF system. So we're now going to look at Bale. So Phil, if I can ask you to share your screen.
Yeah, okay, just 1 second.
We are a little bit behind, Phil, so I will try and give you some time at the end to answer some questions as well.
No problem.
Thanks to everyone at home for your patience with the technical glitches that we've had. We're not doing too bad. We're almost on time, and this is the fourth presentation in this session. So, Phil, I can see that really well, so I'm going to disappear. Enjoy your presentation. Over to you.
Brilliant. Thank you, Harvey. Okay, hi everyone. It's lovely to be here to talk with you today. Although it's not in person, but it's great to see that we can carry on with events like this. So yeah, I'm here to talk to you about Bale building. I'm here representing Bale Building UK. So I'm on the board of SBUC. And also I have my own Bale building company, Huff and Puff Construction, and we have a stand there in the centre. When people can go to see it, and for the people who are there, you can go and see it. And so yeah, so really straw, you can understand that natural materials in construction, we're really looking at trying to green construction, seriously green construction, by using natural materials that are going to help us address the climate and ecological emergency that we're in. And so we really need construction to be real zero carbon, so we're not fiddling around the edges or trying to offset things. We need real action on the fabric of the building itself and all the other things related to that. So you've heard a lot today, I'm sure, about fabric first approaches like a passive house. So we're now getting into the actual materials that we're going to use as well. So, you know, we have some challenges here. Certainly, as you can see from the little cartoon there, you know, it's been a difficult year. And already before that, we knew that, and we've known for a long time that we've got some serious issues to deal with in order to be able to try and make our lifestyles more sustainable, to try and avert some of the issues that are coming up very quickly on us. So just a few facts and figures. I mean, our built environment in total, so in building it and in use, accounts for about 45% of our carbon emissions in the UK. So, and it's an important thing to try and change. The actual construction process itself, all the way through from extraction of materials through to the end of life and disposal of buildings, is responsible for about 10% of UK carbon emissions. So, you know, we've got a chance to really do something serious with construction. And the fabric first approaches like a passive house are absolutely vital, but we need to do more than that. And what we haven't really done very much in the UK, although things are getting better, as we just heard in the last talk with Robin, is, you know, what we can do to actually make materials better in construction, and what we really need. You may have heard terms like cradle to cradle and circular economy. We need to look at where the materials are coming from, how we use them in the buildings themselves, and then what happens to them at end of life. Can they be repurposed? Can they be recycled? You know, all these different options in order to be able to make sure that we can continue doing what we need to do as a society and a planet. So yeah, so how can self-build be part of that solution? So, you know, think fabric first. So, you know, we're trying to look at the materials that we're using within buildings, and trying to get the design right, trying to get the positioning right, lots of different sort of principles as part of the passive house things that I'm sure you've heard today. But definitely also looking at how we can use local materials. So we've got, you know, quite locally to us in the UK, we've generally always got some timber, there's straw, there's clay, there's earth, all these different materials that traditionally we've used in buildings. So down in the southwest where I am, there's a big tradition of, you know, cob buildings. You know, thousands and thousands of these buildings exist and they're still doing really well. And there's a real future for natural materials in construction. And also these are then, by virtue of the fact, lower embodied energy materials. So really my sort of guiding principle with natural building is that we're trying to make as much of the volume of the building as low embodied energy as possible. So we're always going to need bolts and screws and different bits and pieces to some degree or another. But hopefully, you know, we're really reducing that to a very, very tiny percentage of the materials that we're using in buildings. And also invariably over time, there's a lot of unpleasant and even toxic materials that we've used in buildings that we really need to do something about, because importantly, as we'll talk about in a moment, when we've got buildings that are airtight, we need to make sure that the indoor air quality is useful as well. And again, thinking what happens at the end of life of a building, you know, and how long will the building you build last? So with natural materials, we can make buildings that are going to last a really, really long time. They'll have, you know, standard maintenance like other buildings will need as well. But actually, is it a building that looks so ugly that you're going to want to pull it down in 20 years' time, or is it going to be a beautiful thing that you're going to want to change? So with post and beam, timber buildings and straw buildings, generally, I think you look at them and say, well, no, actually, we can work with this and do something else with it because it's a beautiful thing. We don't need to knock it down and start again. So let's look at what straw is. First of all, it's not hay. So it is an important distinction. Hay is a foodstuff, a grass, if you like, and potentially could degrade quicker. Straw's much more similar to wood, really. So it's the dry stalks of cereal plants, so principally wheat, normally in this country, and we're looking at using other exciting things like miscanthus as well, in order to be able to build buildings with bio-based materials. And kept dry, it will last forever, just like wood. So you just need that protection with it, which any well-detailed building will give you. It's an agricultural byproduct, so we don't even have to grow something especially in order to be able to have the straw that we can use for buildings. It's there already every year. And actually there's enough spare straw every year to build all the new houses that we build every year in the UK from straw. So it's literally there ready to use. And that's a tremendous amount of cement and sand and aggregate that we wouldn't necessarily have to use in construction. We could be eliminating all of that, or a great proportion of it. So invariably, lots of questions come up about straw bale buildings. You know, what if the big bad wolf turns up and it all blows away? You know, and invariably one of those questions is, for example, what happens with fire? And it's a good example of how natural materials are actually incredibly resilient in many different ways. So for fire, for example, straws, basically the bales are like big lumps of wood. They're compressed very tightly into walls, which means they have very little oxygen within them. And the render on the outside of them increases fire protection. So it's a bit like trying to set fire to a phone book. If you had a standard straw bale, you might get a bit of surface charring on the outside of the bale, but it would take a really, really long time to burn all the way through. The render on walls protects them. So there's just an example here with a building that was sadly destroyed in California in the wildfires that they have out there. They have lots of straw bale buildings out there. And you can see that the whole building is completely gone, apart from the straw bale walls, which are still left standing and haven't even really burned through the render seriously on them, let alone getting to any straw. So, you know, it works really, really well. Lots of other questions, which maybe we'll pick up in the other things, but a well-designed building, they work very well. So we've talked about some of the benefits, again, you know, addressing the green option, but even if you're not overly interested in that, it simply gives you a fantastically insulated building. So with wall U values, where we're looking at the lower value being the better, you've got a U value of around 0.1 for straw bale walls. 0.3 is what regs require, and a decent cavity wall might be around 0.2, maybe a little bit less than that. So you're getting a fantastic insulated wall all the way through the wall. As far as SAP scores go, you can really get, you know, the maximum SAP score available. You can do pretty well, even if you're not aiming for passive house in its entirety. You can do pretty well and get up there on a really, really high score. They're easily cement free. Yes, you know, lots of things, and it's good that lots of things are being done to try and green cement use. But sadly, of course, you know, that doesn't change the fact that, you know, they still use a lot of aggregates and other things that we're running out of as well. You know, so we can have easily cement-free buildings, buildings that are zero carbon in construction and use. So you're looking at a building that potentially is cost neutral compared to other systems up front, and longer term, you can be saving that money by having fantastic other benefits from insulation, etc. in the building. And you can build all sorts of buildings from straw. Yeah, you know, there may be some structural limitations here and there, but they can generally be worked out by using different methods. So you could, for example, be using timber beams or even steel in certain aspects of trying to achieve things with straw bale buildings. So we're very much trying to look to do the best of old building practices and the best of the new. So we're trying to take those great things that old buildings have, like using local materials, reusing materials, accommodating movement. That's important because straw bale buildings have a certain amount of flexibility built in. They're actually, not that we have such a problem here, but they're fantastic in earthquake zones because they're incredibly resilient and it's almost impossible to make them fall over. They work with moisture rather than against it. So we're looking at buildings that are effectively breathable, vapor permeable. They're simple to maintain and they feel good. So how does that compare to new buildings? Well, sadly, many newer buildings still are very complex, resource hungry, and energy intensive, and contain quite a lot of toxic stuff. But on the whole, they are better insulated and therefore use less energy, which is absolutely great. So we can put all those things together with straw bale buildings. So we're looking at that fantastic insulation, low energy use. And again, using things like clay plasters internally, we can achieve amazing indoor air quality by regularizing both the internal temperatures and humidity by using some thermal mass on the inside of the walls. And also they're really good soundproofing. Quite often one of the things that people say about straw bale buildings, similar to, for example, a stone building or any sort of a massive building, a cob building, is that you just feel very cocooned within them and very safe, which is a lovely thing to have in a home, of course. So just a word about some of the construction types with straw. So there's load bearing, where all the weight's on the straw. There's infill, for example, using a timber frame infilled with straw. Hybrid combinations of different methods, and importantly now panel systems, and then of course retrofit. So we'll just look at those in order. So with load bearing straw bale, this started in America. Basically, they didn't have, out in Nebraska, they didn't have anything to build their houses out of, apart from when they introduced the baling machinery. They had a lot of hay and straw, so they started to build houses out of straw, and that's where the first straw buildings came from. And there are still some out there from back then. There's also one in Paris, a famous one in Paris, and lots of different buildings from quite a long way back. So, we've got some history with straw, as well as all the tens of thousands of years that we've been using straw in building generally. So just looking at load-bearing straw bale, you've generally got a timber beam at the top and the bottom of the wall, and the bales themselves are sort of running a stretcher bond around the building. And this sort of system is then, the important thing to note is that it's all compressed tightly together. So we use ratchet straps, or the roof is put on to hold everything down. And this system is good for at least 2 stories. However, and I love it. It's a great system. It is difficult for some people to get their heads around, to understand that it would ever work. So actually, a lot of what we do more now is infill straw bale into a timber frame. So you're getting the benefits of some structural timber along with the straw for the fantastic insulation. And that straw can go either within the frame or on the outside of the frame. Of course, insulation generally as a rule should be on the outside of what you're trying to build. This is an example of one of the buildings that we do. So this is our Huff Puff house. And this is designed for hands-on self-builders. So you basically get a timber frame, which is you effectively create the roof and the walls all in one go, and then you load the straw in between the frame. This is a more standard approach that we do for buildings, where you can see a lot of timber posts there. Some of those will be around doors and windows. But they're also able to support the frame and the roof whilst the straw is loaded in. And so the straw is then put into the frame. And to do that, you can see a picture here of we compress the straw into the frame. So once that's released, there are big steel plates on the top of the straw there. Once we pop the top bale in, we release the compression, and that's held very, very rigidly. And you can see an example here of a large post and beam frame. You can see the frame inside the building and the straw walls around the outside. And I think there's kind of a reputation with straw bale buildings that they kind of are very sort of, chocolate boxy, rural sorts of things. And SBUC's been involved with an Interreg project called Upstraw to promote straw in urban and public buildings, because straw bale buildings really can be as crisp and neat and look pretty much however you want them to look. They don't just have to have that lumpy bumpy look to them that you might see out in the countryside. They can be very crisp, very clean, very modern as well. This is a trimmed straw bale wall getting ready to receive its render. So hybrid straw bale method is just a combined method. So very simply put, that might be, you might have a brick house and you might want to put an extension on it. That extension could be a straw bale extension and could help to overall bring up the energy rating for your house. And finally, and perhaps most excitingly with straw bale, and the way that straw bale is really going to get to scale in the UK is using panel systems. So we can supply systems like EcoCocon, who also have a stand there in the NSBRC. And you've got ModCell based in Bristol, and there are oncoming other systems to do with straw bale systems, panel systems, where basically we touched on potential issues with straw, and one of them is moisture. So that's only ever going to really be an issue during construction with straw. So the sooner you can get all the materials on site and get them weatherproof, the better. And panel systems are a great way to do that, because you might be able to get easily within a week all of your panel systems up and your roof onto the house. And so you're looking at factory quality there and speed of construction and speed to weather tightness on site. So that's really, really exciting. And finally, retrofit. A less explored area with straw, but you can do bale wraps on buildings. There are different things that are being looked at to do retrofit. And retrofit's really important, just because we only build, we only replace about 5% of housing stock every year with new builds. And whilst it's important to get them right, we do also, need to look at everything that exists in order to be able to meet the targets that we're trying to meet. So we can use straw for that as well. And there's various exciting ways coming out to be able to do that, with not just with straw, but also with other bio materials. So just quickly look at some design details. So generally the straw bale building, had a word with old Bob, the cob builder, and he would say that you need a good hat and a good pair of boots, which is important for any building really, but certainly with straw bale buildings, that's generally what we want to have. So you're just looking at keeping the straw up off the ground. So generally the straw won't start before about 450 mil up off the ground. And the eaves on the building will generally be a little bit bigger. So you might be, up to 500 mil or something, or you might have an overhang, or you might build in a veranda, or, whatever would suit the design of the building. So again, looking at some of the things that we're trying to do, we're trying to minimize the use of cement. We don't need any ordinary Portland cement to be used in straw bale buildings at all. We're minimizing the use of high carbon and high embodied energy materials. We're sort of looking back in many ways to pre-ordinary Portland cement building. On the outside of the buildings, we use lime render quite often, and there's energy associated with that as well. So it's not a get out of jail free card. We also just need to be able to generally be keeping an eye on how we're using materials and what we're using, and trying to make it as green as possible. Yeah, and they're vapor permeable, which is an important thing. Talking about the internal air quality, we're able to regulate various different things and make sure that whilst we're having an airtight building, it's not one that doesn't breathe, which is important for our health too. Various materials that we can use in foundations. This is a good one. This is foamed glass gravel, which comes in various different shapes and forms. And so, for example, instead of a concrete floor or slab or rafter foundation for a house, you could use a makeup with this foam glass gravel, which is literally made from recycled glass from bottle banks. That can be used as a makeup, say about 300 mil of that, and then 100 mil of limecrete screed on top, which could have underfloor heating in, that sort of thing, to go with a heat pump or similar. Pier foundations, so you can see an example of some car tire foundations in here, and all we're just using that is just simply as a pier, which is a free draining pier. It's filled with gravel to keep the timber up off the ground, the regulation 150 mil. And then the other insulation you might be using in the house, you can use other bio-based materials, so straw, wool, hemp, wood fiber board, all these different materials that can be used to help to green your construction method. And then as far as finishing goes, we can see some people getting their hands muddy and putting some clay plaster onto some internal walls, which is great because you can all have a go at that and get people involved, even young people. Love to have a go at doing that sort of thing. Lime, of course, we have to be more careful with, but lime render on the outside and even timber cladding on the outside. This is an example of a building that we're actually working on in Hastings at the moment, which is a visitor centre at the country park there. And you can see this has been used with a rain screen timber cladding. which physically separates the rain from the wall. So, and this is 150 meters up on the edge of a cliff in fierce weather quite a lot of the time, but straw works in situations like that as well. So a few notes just on building. You know, it's an accessible building method. So if you want to get hands-on with your self-build, there are options there to do that, and that might help you with some of the costs involved, although you should never underestimate the value of your own time, of course. And just get advice with straw from specialists earlier on. You know, people like my company, you can come to SBUC and we can point you at people. You can go and find people who can help you with straw bale building. I'm not going to say it's as easy as with other methods, but for, you know, certainly building control is no problem. Mortgages and warranties are available for straw bale buildings, and it's getting easier all the time. And in order to try and assist that, SBUC are actually working towards many sort of agreed details and standards for straw bale, which going forward will make things a lot easier. Yeah, so there we go. I think that's it. It's on about 20 minutes, Harvey. So that's ready for some questions. I think there's the details there on the screen.
Great, thank you so much, Phil. That's brilliant. Really enjoyed that. Right, straight into questions then, if that's okay. So I'll pick this one first, because you've mentioned it already. You just mentioned about finance, and I think it was Nick asking, can you get commercial finance for a straw build home?
Yeah, you absolutely can. You may have to search around a little bit more, and obviously things like mortgages, etc., are obviously going to be dependent on your own situation as well. But most of the big lenders will absolutely consider it. And you can also go to places like the Ecology Building Society, who have their own straw bale building, in fact, who will very much be a good port of call to ask for mortgages and those different sorts of things. So yeah, I'm not saying it's as easy as it is for everything else, but there's certainly options out there, and it shouldn't really be a huge barrier.
Great, thank you. This one didn't have a name attached to it, Phil, but you showed some photos and mentioned the Conocon as well as the Huff and Puff system in your presentation.
Yeah.
Those panels are, I think, are manufactured in Europe. So this attendee's question is, are there any panels or systems that are produced in the UK? And is it an issue if they're manufactured in Europe?
Yeah, no, it's a really good question, and I think it's important with you know, it's common with a lot of the greener building materials. We don't necessarily seem to make them in the UK at the moment, and it's a bit chicken and egg, because of course if we don't use them here, then we'll never actually have people here who are going to make them closer to where we need them. And I think if you speak to EcoCon, you know, they will say that, you know, although the panels are manufactured in, I think, Lithuania or Slovakia, you know, they're still zero carbon by the time they get here, and they're only coming here once, you know. So you know, so there's that to consider. But of course, you know, we want panel systems made in the UK, and currently we have companies like Modcell, who are based in Bristol, who do straw bale panels. We're looking at doing straw bale panels. Lots of people are looking at straw bale panels. Actually, the panel systems are much more common with our European neighbours at the moment, certainly in Northwest Europe, and there's, you know, discussion going on with them about different things. Yeah, things like the foam glass, for example, as well, comes from probably Germany or Austria, you know, but we have enough recycled glass here to make a lot of it too. So it's one of those things where it's a bit chicken and egg. We just need to use it a lot more, and then we have the materials here where we need them as well.
Great, thank you. You touched on air tightness and air quality in your presentation. Tracy was just asking if you could expand a bit on how do you achieve air tightness with a straw bale wall construction?
Yeah, absolutely. So, I mean, the main thing was with the walls themselves is the straw is compressed into them very tightly. So from an air tightness point of view, the straw in the walls for the height of the wall pretty much takes care of itself. But as I'm sure you might have heard in some of the talks about passive house approach and fabric first, really the main thing that you need to look at is the junction. So that's between the wall and the floor at the base of the wall, and then the wall and the roof, or similar, at the top of the wall. And those are areas, and thirdly, service penetrations through the wall. So around doors, windows, pipes, those sorts of things. And those are areas where really you need to be, ideally, I would say, using an air tightness tape, a suitable air tightness tape, and you can get them that stick to straw amazingly as well, and use that in the finishing of the building to get a really well detailed finish, which is going to make it an airtight building. It's important to say that actually, you know, you can lose a lot of, you know, very humid air through gaps in holes, and that's something that you don't want going through against the straw, because potentially that's going to make it moist. And the only issue with straw is really if it's going to get overly wet. You know, it can tolerate moisture very well up to about 30%. But you know, gaps in walls are things where you need to detail them very, very well. But yes, there's, you know, those are the things that you need to be able to do to get it right.
Great, thanks, Phil. Yeah, and just on that area, again, it's an anonymous question, just about what do you do to counteract mold and effects if you suffer from allergies? Is there anything in particular that you can do in that situation?
Yeah, absolutely. So basically, you know, if you shouldn't ever have a situation where the straw is getting overloaded with moisture. Something would have gone very badly wrong, or it hadn't been designed very well if that was the case in the first place. So actually, indoor air quality is an area where straw works really, really well, because if you're using something like a clay plaster internally, what happens is, whereas in a building, if you had, you know, plastic paint on the wall or wallpaper or different things, generally moisture will condense on the surface, and that's how you get mold growing. It grows on that moisture on the wall that's sitting on the surface. So a clay wall, for example, pulls moisture in deep inside it, so you kind of avoid getting those issues with mold in the first place. So it's actually a really, really good way of having a healthy building without any extra, you know, things to do.
Great, brilliant. Phil, I'm going to leave it there. Thank you very much for your time.
You're
joining us again at 3 o'clock, aren't you, for the final question time session? So
absolutely.
Thank you. So yeah, and thank you for allowing us to catch up a bit on the time as well. Apologies for slightly overrunning. Yes, we'll be back at 1:30, and it's going to be Chris Stanley from the Modern Masonry Alliance, so another system for building. So thank you very much for your time for joining us this morning. I just wanted to just show you one thing very quickly before we break for lunch. So if you want any more information about any of the companies that have spoken today or any of the exhibitors here at the centre, if you visit the NSBRC website, nsbrc.co.uk, click on the exhibitors tab and then exhibitors on display, it will tell you more information about all the companies that we have here in the centre. And if I click on Huff and Puff, just as an example, it will tell you their stand number and where they're located and give you their website. But if you just fill in a few details, your name and contact details, and submit that form, this is the same on each page, that will go directly to Phil and his team, and they can send you information. So that's in these times, if you're unable to travel and attend the centre, if you want to do some more research over the Christmas break, that's a really helpful thing that we have all the time in the centre, so you can carry on doing your research and get more information sent to you. I'm going to leave it there. Thank you very much. I hope you've enjoyed the morning session. Go and grab something to eat now. You already know that I've been snacking on mince pies because I forgot to turn my camera off early. So, and I will open up the next session at 1:15, so in about 10-15 minutes time, and we'll be back starting at 1:30. Thanks very much, everyone, and see you in a bit.